Good morning, students of 12th standard of St. John's. Yesterday we started chapter 9, applications of integration and basic formulas of integration, which we have studied in 11th standard is given first. So after that basic formulas, we went for calculating a Riemann integral of three types: left end rule, right end rule, and a midpoint rule, and corresponding formulas. And based on that, two problems each in each type we did. And finally we saw the formula for finding integral value, that is definite integral value, integral a to b f of x dx, using limit formula. So yesterday we have studied this formula, limit formula to evaluate integral a to b f of x dx. So with this formula only we are going to do few problems in this class. So delta x, already we have discussed the formula for finding delta x is b minus a by n, where a is called the lower limit, b is called the upper limit. So upper limit minus lower limit divided by number of partitions n. And the formula for evaluating the integral a to b f of x dx is given by limit delta x goes to 0 delta x, sigma r varies from 1 to n, f of a plus r delta x. I asked you to memorize this formula, which is helpful for calculating the value of definite integral using limits. So how to calculate the value using this formula, we will discuss that through problems that we are going to do. How the formula starts? The formula name is limit formula to evaluate definite integral. So since it is a limit formula, the formula even starts with the limit. Limit delta x goes to 0, delta x, summation r varies from 1 to n, f of a plus r delta x, where delta x is given by b minus a divided by n. And also I said that these are all the formulas that we studied in 10th standard. Yesterday we saw this. Sigma n is nothing but sum of first n natural numbers, and it is given by n into n plus 1 by 2. Sigma n square means sum of squares of first n natural numbers. The formula is given by n plus 1, 2n plus 1 by 6. Sigma 1 means n. Sigma n cube, sum of cubes of first n natural numbers, and it is given by n into n plus 1 by 2 the whole square. So yesterday we have seen all these things. Now with the help of the limit formula, we are going to evaluate the value of definite integral. We are going to do few problems using this concept. Problem number 4. Evaluate integral 0 to 1. So if a limit is given like this, then it is called a definite integral. Yes or no? So when an integration is there with the limits, if you see this is lower limit, 0 is the lower limit, 1 is the upper limit. We need to evaluate this using limit of sums. Again, you just see this wordings. Evaluate this integral as the limit of sums. So we need to apply the limit formula that can be understood by seeing this word, limit of sums. So we have to apply limit formula to calculate the value of this integral. So how to do this problem? Just listen, I'll tell the method of doing it. First, the given function is taken as f of x, and it is equal to 5x plus 4. You know, this is lower limit 0, upper limit is 1. So a is 0, b is 1. Calculate delta x using the formula b minus a by n. So subtract and write 1 by n comes. So delta x is equal to 1 by n. Now you just have to remember the limit formula. This is the limit formula that I have written here. The limit delta x goes to 0, delta x. So the formula we need to find delta x that we found out. Then if you go through the formula, we have f of a plus r delta x. So this is what I want to find next. So I am writing f of a plus r delta x is equal to f of a value is 0 plus r into delta x value is 1 by n. So I am writing that. Since it is 0, it will be reduced to f of r by n, right? Now if you see the first equation, it is it gives the value for f of x. First equation is nothing but it gives us the value for f of x. So I want f of r by n. F of x answer is 5x plus 4. Then how to find f of r by n? In place of x, you have to put r by n. So what happens here? 5 into r by n plus 4. 5 into r by n plus 4. That is the value for f of a plus r delta x. Just understand how I am calculating f of a plus r delta x. Second equation is obtained using first equation. This is what we want. We have f of x. We want f of r by n. So put x in place of x, r by n. So here also r by n. 5r by n plus 4. Now we are writing the formula. Integral a to b f of x dx. Formula to calculate. The limit formula is given by this. Now you understand this carefully. Here it is given the limit delta x goes to 0. What is delta x actually? 1 by n, because delta x value is 1 by n. So if delta x goes to 0, what happens when it will go to 0? Only in the denominator, if is infinity, 1 by infinity is only 0. So what is the meaning? Delta x, if delta x has to go to 0, then the denominator should go to infinity. Then only delta x will become 0. So delta x goes to 0 is same as n goes to infinity. Because 1 by infinity, what is the answer? 0. So try to understand, if delta x has to go to 0 means this n should go for infinity. Then only delta x will go to 0. Could you able to understand this? That is what I am writing here. Delta x goes to 0 implies this n should go to infinity. So in the next step, I am going to change this limit. Limit, instead of writing delta x goes to 0, I am going to write n goes to infinity. Because if delta x goes to 0, n will go to infinity. So change this limit as n goes to infinity. In place of delta x, write the value 1 by n. Summation r equal to 1 to n. F of a plus r delta x value is present in the second equation. Take that and substitute here. 5r plus n, 5r by n plus 4. Hope you are listening, and I hope you can understand. Limit n goes to infinity, 1 by n. Now I am just taking this sigma inside. If you see sigma, r is the variable. R will change to 1, 2, 3 up to n. So r is the variable. So 5 by n is constant. So take that out and take the sigma to r. Plus 4 is nothing to do with r. So take 4 out. When sigma goes inside, it becomes sigma 1. 4 comes out. So sigma 1. Are you able to understand this? Bringing sigma inside. Sigma means the variable is r. R value only changes from 1 to n. So this only is the variable. This is constant. So you can take and write outside sigma. 5 by n is taken outside sigma, and sigma will join only with r. Plus 4 outside. Sigma, nothing is there. So 1. What is this? If I substitute r is equal to 1, 1 plus next value 2 plus 3 plus 4 plus x. This is nothing but 1 plus 2 plus 3 plus 4 plus etc. up to n, which is nothing but sum of first n terms. So this is nothing but sigma n, n into n plus 1 by 2. Could you able to understand how it is? Sigma n means what? 1 plus 2 plus 3 plus etc. plus n. Here also the same concept. If I put r is equal to 1, first term will come. Sigma means plus. R equal to next value 2, 3 up to n. So what is the formula for this? N into n plus 1 by 2. So in place of this, I am going to substitute n into n plus 1 by 2. And also we know sigma 1. What is the value for sigma 1? We have studied this. Sigma 1 is equal to n. So here I am going to write n. That is what will be written in the next step. And limit n goes to infinity, 1 by n. So if you see, in place of sigma r, I will be writing n plus 1 by 2, and here in place of sigma 1, n. Now this n and n gets cancelled. Remaining thing I am writing here, 5 by 2. Listen carefully, 5 by 2. Now from this bracket, take n outside. from this bracket, take n outside. So here n will become 1. Here 1 means 1 by n. So this step comes because of taking n from this bracket, taking n outside. So this becomes 1, this becomes 1 by n plus 4n. In the next step, limit n goes to infinity, bringing this 1 by n inside. What will happen? This n and this n will get cancelled. So 5 by 2, this alone remains. So when it is taken to the next term, again n cancels, so 4 remains. Now I am going to apply the limit. Applying the limit means what? Substitute n as infinity. So 1 by infinity. What is the answer for 1 by infinity? Answer is 0. So this will become 0. So 1 remains. 5 by 2 into 1 is 5 by 2 and this plus 4. So when you cross multiply 8 plus 5, 13 by 2. So answer is 6.5 square units. Why we are writing square units means we are calculating actually area of a curve under the given limit. So that is the meaning for this question. We are calculating actually the area of a curve under the given limits. Hope you would have understood this sum. Here main thing is the formula. What formula? Limit formula. And after that we should know 10th standard formulas also. Sigma n square, sigma n cube, like that. Now we will see same model problem. Question number 5. Evaluate integral 1 to 2. This is the limit actually. This is the function. This represents a curve. Actually what we are finding here, we are finding area of this curve under the limit 1 to 2. That is the meaning. So how to start with? This function is taken as f of x. Lower limit is called a, upper limit is called b. Delta x means formula is b minus a by n. So 2 minus 1, 1 by n. Delta x value we found out. After finding delta x, what we have to find out? F of a plus r delta x, because this is required in the formula. F of, what is a? 1. So 1 plus r. Delta x value is 1 by n. So this will become f of 1 plus r by n, right? But see what is f of x? F of x means 4 into x square minus 1. So in place of x we are having 1 plus r by n. In place of x we are having 1 plus r by n. So what happens here? 4x square. So 4, this is x. So 4x square minus 1. This is by using first equation. Try to understand how I wrote this. This is f of x. What is f of x formula? 4x square minus 1. So this is x. 4x square minus 1. So now expanding this in a plus b whole square. A square plus b square plus 2a. A square means what? 1. B square means r square by n square. 2ab means 2 into r by n, right? So applying the formula a plus b whole square, we get this 4 into, this is a square plus b square plus 2ab, and then this minus 1 is already present. So simplifying this, if I bring this 4 inside, what happens? 4 into 1, 4. 4 into r square by n square. 4 into 2r, 8r by n minus 1. Now combine the numbers. 4 has to be combined with minus 1. 4 minus 1, 3, and these two are written here. So this is the value for what? F of a plus r delta x value is this. That is taken as second equation. Now after finding f of a plus r delta x, we will write the formula. This is the limit formula that we studied. In this we have already know, if delta x goes to 0, n will go to infinity. Why? What is the reason? Because delta x is 1 by n. Delta x has to go for 0 means this n should go to infinity, because 1 by infinity is 0. So delta x goes to 0, the meaning is n goes to infinity. Now we are going to change this limit as limit. Instead of writing delta x goes to 0, we will write n goes to infinity. Delta x value is 1 by n, summation f of a plus r delta x value is this. So writing all these things inside the bracket. Now bringing this sigma inside. Since 3 is a number, 3 into sigma 1 will come. When I take sigma to this term, sigma's variable is r, because r value changes. So it will go only with r square. 4 by n square will come out. Sigma will go for this r square. Similarly, plus when sigma comes with this term, again it will go only with r. 8 by n will come out, sigma r. So 1 by n, 3, we know very well sigma 1 value is n, right? Sigma 1 means n. So plus 4 by n square, sigma r square. So this is nothing but sum of squares of first n natural numbers. Formula is n plus 1, 2n plus 1 by 6 plus 8 by n. This is sum of first n natural numbers, n into n plus 1 by 2. So everything is based on two things. One is this formula and the other one is 10th standard formula, sigma n square, like that. So now cancelling this n, and limit n goes to infinity, 1 by n, 3n plus. Now try to understand this step. 4 is written here, divided by n square is written here, 6 is written here, and from this 1n is present. And what I am doing is, from this bracket I am going to take 1n outside. Already 1n present. From this bracket, if n is taken out, this becomes n square. From this bracket, if another n is taken out, this becomes n cube. So taking out n from this, also from this, so it becomes n cube. If n is taken outside from this, what happens here? 1 plus 1 by n. Similarly, if n goes outside, 2 plus 1 by n. So n is taken outside and the remaining is written here. Here n gets cancelled now, so 8. From here also, you just take 1 n outside. If you take 1 n outside, here even I can cancel this, right? 2 can be cancelled with 8 and becomes 4. So I should not write 8 here, I should write what? 4. And if n is taken outside, this is 4 actually, 4. If n is taken outside, it becomes 1 plus 1 by n. Yes or no? So limit n goes to infinity. Now bring this n inside. If n comes inside, n will get cancelled, so only 3 presents. If 1 by n comes to this term, if 1 by n comes to this term, here already n square, n cube, if gets cancelled, only 1 n remains. That will get cancelled with this n. So only 4, this bracket and this bracket only remains. Right? Because here 1 n square, here 1 n. N cube cancels with n cube. Plus, this is not 4. What is this? So this is not 8. Actually that is 4. So 4 into, if this 1 by n comes here, this n and this n will get cancelled. So 4 into 1 plus 1 by n. Now I am going to apply the limit. Now see, if n applying the limit, what is the meaning? Substitute n as infinity. So here we cannot substitute, so 3 will come as it is. Plus, if you put infinity here, 1 by infinity becomes 0. So only 1 remains. So 4 into 1. If 1 by infinity is 0, so 2 remains. 2 plus, this is not 8, that is 4. So 4 into, this becomes 0, so 1 remains. So 3 plus 8 plus, this is not 8, this is 4. So the answer is 15 square units. So the answer is, why we are writing square units? I told you 15 square units, because we are actually calculating the area of a curve under the given limit. So these are all important sums. Listen and understand carefully. Now in the next heading, fundamental theorems of integral calculus. We have two fundamental theorems on integral calculus. The first fundamental theorem is given by, if integration of this function small f of x, and if the answer is capital F of x, what I am telling, the integration of small f of x, if the answer is capital F of x, then the differentiation of this capital F of x should give small f of x. This is called first fundamental theorem. And this is nothing but, it is a statement of telling differentiation and integration are reverse process, because when we integrate this, this is the answer. What is the reverse process? When we differentiate this, the answer should be small f of x. So integration and differentiation are reverse process. That is called first fundamental theorem. Second fundamental theorem, integral a to b f of x dx. And we know very well integral f of x dx is capital F of x. If the limits are given, then we have to substitute the upper limit first, f of b, then minus, then substitute the lower limit, f of a. This is the way of calculating definite integrals. We know very well if there is no limit, integral f of x dx is capital F of x. If the limit is given, first apply the upper limit, so f of b, put minus sign, then apply the lower limit, f of a. So this is called second fundamental theorem. Then we will go for properties of definite integrals. First we should know what is meant by definite integral. Definite integral meaning is the limit is known. If the limit is not known, like this is called indefinite integral. If limits are present, that is called a definite integral. Now we are going to see what are all the properties of definite integrals. Some 12 properties we are going to see. So you have to thorough with all the 12 properties, then only we can move to the problem sections. So your basic aim is to learn all the 12 properties thoroughly. Property 1. Integral a to b f of x dx is equal to integral a to b f of u du. The meaning is, if the limit is present, we need not worry about the variables. Even if it is f of x dx or f of u du or f of z dz or f of a dA, everything will give the same answer. If limit is present, we need not worry about the variables. F of x dx or f of u du will give same answer. That is property 1. Property 2. Integral a to b f of x dx can be written as minus of integral b to a f of x dx. So the limit can be interchanged by putting a minus symbol. That is what property 2 says. Property 3. Integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. The important thing is c should lie between a and b. In between a and b, if c is a point, then this integral can be splitted like this. Instead of going a to b, we can go to a to c and c to b. A to c plus c to b. Like this we can split and write. That is what property 3 says. Property 4. Integral a to b alpha f of x plus beta g of x into dx can be written as, that is, if two functions are there present with the plus symbol, two functions are there in the integration, we can split the integration into two, in which first function can be taken for the first integral and the second function can be taken for the second integral, in which first one, when you write this, constants can be taken outside the integral. Alpha is taken outside, only f of x dx is written in the first integral. In the second integral, beta g of x, since beta is constant, it can be taken outside. G of x dx is written in the second integrals. Like this, like that, we can split and write. That is property 4. Property 5. Integral a to b f of x dx can be written as integral c to d f of, if x is equal to some function of u, that can be substituted here. In place of x, I can substitute g of u. But here, the differentiation of g of u into du. So dx is changed to u. What we are doing? We are changing the variable from x to u. How to change? In place of x, put g of u. Differentiate that g of u with respect to u and then integrate with respect to u. Don't get confused. Just read the property. When it is applied in the problems, you will understand. Where the c is nothing but g of a. So in g of a is nothing but c. G of b is nothing but d. That is why the limit changes here. Instead of a, I am writing c. Instead of b, we are writing d. Because g of c is a, g of d is b. Property 6. Integral a to b f of x dx can be written as integral a to b f of, I can add these two. a plus b minus x. This x can be replaced as a plus b minus x. These two will give the same answer. That is what property 6 says. Integral a to b f of x dx can be written as a to b f of, in place of x even we can write a plus b minus x. The answer will not change. Therefore, what is 0 to a f of x dx using this property? This is a, this is b. Add these two. What happens? A comes. So, x can be replaced by a minus x. Using this property, we can write this. Adding these two. So, if you add these two, a will come. So, this can be written as a minus x. Property 7. 0 to 2a. Integral 0 to 2a f of x dx can be written as integral 0 to a. See the limit 0 to 2a. Here it is 0 to a f of x. We are writing the function into two types, f of x plus f of 2a minus x into dx. But the limit has to be changed to 0 to a. Here we will get two functions. One is f of x, other one is f of 2a minus x into dx. Both will give same answer. Property 8. Integral minus a to plus a f of x dx can be written as 2 times integral 0 to a f of x dx. If you see, the numbers should be same. One should be minus, lower should be minus, upper should be plus. If it is like that, we can write 2 times 0 to a f of x dx only if f of x is an even function. If this f of x is an even function, then we can write this as 2 times 0 to a. What is meant by even function? The definition is given. When in f of x, if we replace x by minus x, then also answer should not change. If f of minus x and f of x are equal, then the function is called as even function. Example is cos x, because cos of minus x and cos x are equal. Therefore, it is an even function. So, we can use this property only for even function. Similarly, property 9, the same thing, minus a to plus a f of x dx. The answer can be directly written as 0 if f of x is an odd function. Odd function meaning is, if f of minus x equal to minus f of x, f of minus x is equal to minus f of x means the function is said to be odd function. Example is sin x, because sin of minus x, answer is minus sin x. So, f of minus x is minus f of x. So, this is called odd function. So, when odd function is present here with the limit minus a to plus a, directly we can write the answer is 0. So, this is for even function, this is for odd function. Property 10. If f of 2a minus x and f of x are equal, if this condition we are having, then integral 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx. We can take this only if this condition gets satisfied. That is, if f of x and f of 2a minus x are equal, then we can write this integration as 2 times 0 to a f of x dx. So, you should be very careful in reading all the properties. Read the properties with the insisted condition. Property 11. If f of 2a minus x equal to minus f of x, if you see here 2a minus x equal to f of x, here f of 2a minus x is equal to minus f of x, then this integral 0 to 2a f of x dx answer is directly can be taken as 0. So, with the condition you have to learn, that is the most important thing. Property 12. Integral 0 to a x into f of x dx can be written as a by 2 a by 2 integral 0 to a. Now we need not write this x, just f of x dx. The condition it should satisfy is f of a minus x and f of x should be equal. If these two are equal, then this type of integration we can remove x, no x present here, just f of x dx, but in front I have to write a by 2. A is nothing but the limit, upper limit. So, a by 2, 0 to a, only f of x dx. So, this x can be omitted when if f of a minus x and f of x are equal. Only if this is in our hand, we can take this result. And two notes are given. One is integral 0 to pi some function of sin x dx can be written as 2 times 0 to pi by 2. If the function should be some function of sin x, limit should be 0 to pi, then we can write that as 2 times 0 to pi by 2, 2 times 0 to pi by 2, the same thing, g of sin x dx. So function of sin x is present, limit should be 0 to pi, then it can be written as 2 times 0 to pi by 2. The next final note, integral 0 to 2 pi, here 0 to pi, this is 0 to 2 pi, this is function of sin x, this is function of cos x. G of cos x dx is equal to, again this can be written as 2 times 0 to pi g of cos x dx. Again 0, limit should be 0 to 2 pi, it should be cos x function, that can be written as 2 times 0 to pi, the same function, g of cos x dx. So all these 12 properties and 2 notes you have to read thoroughly, then only you can understand the problems to follow. So it is important that you write and practice in your rough notebook all the 12 properties, even just you say it by your own, just try to memorize all the 12 properties thoroughly, then we will enter into the problems. Hope you are all revising the subject regularly, daily at least half an hour to 45 minutes you have to spend. Apart from writing the classwork, you have to spend half an hour to 45 minutes to revise what is being taught on that particular day. If you do this regularly, no matter whether you are coming to school or not, still you can able to score the maximum marks. Still you can get a very good knowledge of the subject. Thank you, children.